Please welcome Edge Impulse co-founder and Qualcomm Senior Director Technology, Jan Jongboom.
All right, closing it out. And the last person to stand between you and happy hour. So traditionally, at least for the 3 Imagines that I was prior to this, someone would bring me a beer on stage. But that has not happened. So can I ask someone from staff to go do that? That would be great. So on July 29, 2025, about 2 months ago, something happened that I did not anticipate when I started writing the original source code for what became Edge Impulse 6 years later. This was our raw data table, the table in our database where we store all the samples that people upload. And if you are a software developer, you might think, hey, that is actually a very round number. Because on that day, we hit an overflow in some of our data, and this is the basically the max value of what fits in a int32. And stuff got on fire, and people saw things like this in the studio. And this is funny, man, because the code that was responsible for this was basically written in July 2019. It's the code that basically stores all of the samples that you have in a NumPy file while you're generating features. And at the time, I just had no idea that we would ever have more than 2 billion data samples in our database, and that we needed to start thinking about that already at that point. But here we are, man. It's truly fucking astonishing how much this community has grown. And even just from last Imagine, we've over 200,000 new projects on Edge Impulse in just a year's time. It is absolutely incredible. We have 225,000 plus developers. Yeah, as Zach said this morning already, like more than 1 billion new data samples since last Imagine, 2.3 billion today. That is 31 new samples every second of people just capturing data, accelerometer, audio, images, whatever, and uploading it to the system. It's truly astonishing. And one thing that I started tracking only since last year, the number of papers that people write mentioning Edge Impulse in Google Scholar. 1,600 now, up from 850 last year. So even in the academic spheres, people are really picking this stuff up and using Edge Impulse to write their theses, which I think is really cool. Really, really cool. Like this graph, it just keeps going faster and faster and faster. So truly, truly amazing. And everyone here, the people here in the audience, the partners, thank you so much, Linda. But yeah, everyone here, the people in the room, our partners, the people on the live stream, the people that will be watching this on demand later on YouTube, this is all you. Absolutely fantastic. So let's go look at some cool stuff that we've done over the past year, and then some new stuff that we're building, and a couple of things that we're actually shipping today. So already, oh, I thought I removed the animations, but whatever. About 6 months ago, right, and I think this is one of the reasons why you've seen the community growth this fast compared to 2 years prior, is that the Qualcomm acquisition has allowed us to also give away a lot more stuff for free than when we were still a standalone company. So on the community plan, you have an hour basically per job on compute time. We have enabled GPU training for everyone. And some of our state-of-the-art models, like FOMO-AD, YOLO Pro, are now available for everyone and not just people on the enterprise side. And I think this is a really big reason why we see such an amazing pickup in our community tier and going faster and faster and faster. This is all there. If you have not tried out any of these things, you'll be able to train much bigger models and do that much faster now. We also shipped a whole bunch of quality of life improvements. These are the things that we normally skip over in these announcements or in these keynotes, but I think it's cool to call out. We finally have filtering on the test data page, which is for me such a huge step up. Thanks so much for the studio team. I heard a couple of people who build stuff. We have the Feature Explorer, which is the little widget that basically shows you data separation after your feature extraction step is now asynchronous. So on large data sets, that will cut down the feature generation time by a minute. That's on 550,000 projects. That's a lot of minutes saved of engineering time. And we have a new nice bounding box editor to make really, really nifty new bounding boxes where you can actually zoom. And again, when we built this initially, we thought, well, maybe people will use it to draw big boxes around beers. But now that we see customers having hundreds of labels because they're doing very complex PCB manufacturing, all of a sudden it's very nice to be able to zoom in and see all those boxes. We shipped a little dynamic threshold changing window as part of the Linux runner and our WebAssembly build. So if you want to change the threshold of, let's say, your object detection model, you don't need to go recompile your binary anymore. You can just do it dynamically. Big time saver. And then we shipped our new public project pages. So if you're looking for a data set, you're looking for a reference project, just something to get you started, you have a one view overview of everything that's in that project. A sample of the data set, accuracy, latency, RAM and ROM info, all in one go. I think at this point we have 35,000 open projects. Just stuff that people have done and didn't keep for themselves, but actually figured, hey, this would be super useful for the rest of the community. Let me open that up. I think really awesome as well. All right, then time series data. We also ship two things that when I look back, I can I'm thinking like, why did it take us so long to ship this? But it's finally here. One is an optional data normalization step right after feature generation. This was never really needed because a lot of our signal processing blocks have normalization built in. Like if you build a spectrogram out of audio, well, there's already normalization in there. But as we also open this up to pre-processed features, lots of stuff where people just put in raw data, this actually is a big increase. And then for event-based time series things, like here tempering on a lock, we now allow you to say, hey, what should the label be if I'm in this window? Well, in this case, it should be temper, right? Even though it's not at the end of the label. And this actually yielded a 10% point increase in accuracy from some data sets that we were. So that's nice. Last year, we also shipped a synthetic data UI. So this allows you to go get data from, for example, generate a bunch of keywords with Whisper, or generate non-voice audio using 11 Labs, generate images, etc., everything in your project. And it's flexible and has a pluggable architecture. And I think that's really key. Like, I want to build as Edge Impulse, right? I don't want to build everything. For the very simple reason that we cannot build everything. We don't know what is the required thing for your specific use case, but rather I want to have a pluggable interface where people can just plug stuff in. So what GlobalSense told earlier about, where they actually say, hey, we have all of these custom blocks and those plug into Edge Impulse, that is awesome. That's what I want to have. Because then I don't need to go build all of this stuff myself with my team. But if you look at the synthetic data UI, there's one thing that is very clearly missing. We have stuff for audio, we have stuff for images, but nothing for other time series data. And that never sat well. And the reason that we can't do that, or couldn't do that, is because there are no big Gen AI models that can just spit out time series data. I can't ask ChatGPT to go give me some fake rotating machine anomaly data on an accelerometer. So our DSP team has worked really hard to go build a hybrid thing. So not completely synthetic, but sort of augmentation thing for time series data that we're shipping today. If you're an enterprise plan, you can use that. And rather than say, hey, I'm going to create something that's completely synthetic, we can take your current data set, your current time series data set, decompose the samples into the trend, seasonality, and noise, and then either manipulate one of those decomposed fragments of your data, or actually say, well, we're going to take the decomposed values from multiple samples and then combine them back together into completely artificial new samples. And we've rolled this out, like we didn't just come up with this on our own. We rolled this out with a leading customer in wearable space, and we've seen actually an 8% point increase in their very challenging to collect data set with the same data just by adding synthetically augmented time series data. So this is really cool. There's a blog post, I think, up today on how you can try this out. If you don't have an enterprise plan, go make a trial and you get access to this functionality. And I think it's going to be a real game changer if you're doing stuff with time series data on a Gimples today. Last year, we also shipped a PPG processing block. So, I come from an embedded background, not from a machine learning background. So my take when we're building a new machine learning algorithm is not, let's take the raw data and throw it in a really big model, and hopefully we'll figure out, the machine learning model will figure it out. It's rather, can we take a look first at what we can do with traditional signal processing, compress that data down, highlight the interesting stuff, and then we can only train a very small machine learning model, and that means we can stuff a lot more on a lot less silicon. So last year we shipped our PPG processing block. That has gotten really, really, really good pickup. It's actually in production with the first customers in really big volumes already. And now we're expanding that to also include an EEG block. So that is pre-processing specifically for EEG. It has motion artifact removal. So we already built that for PPG data. If you have a sensor on your arm and you move around a lot, you get very bad readings, which is why people are using PPG for sleep, because that's easy. You're just laying still. But it's a lot harder for motion, for people in motion. So we added this motion artifacts removal. We do that for EEG too, because it's even more sensitive to this. And then we add a new processing feature, multi-taper PSD. And together, that actually creates stuff like on top you see the same signal, an EEG signal, using sort of a traditional signal processing pipeline. And then at the bottom, you see our new multi-taper PSD approach, and you very clearly see the energy in the alpha band between 8 and 12 hertz. So that's what you expect to see if you have an EEG reading. So this comes exact same signal, way, way clearer, and thus it's going to be a lot easier for an ML model to go pick up on what is happening here based on that data. You don't need to throw more compute at it. And of course, like everything, this comes with both an implementation in the studio, so you can test it out and get the right parameters, but it also comes with a high-performance on-device implementation. So you can roll this out on wearables, stuff behind EEG behind your ear, wherever you want to go or want to deploy that. That is available either next week or maybe a few weeks after. If you want to get early access, go talk to Dan, who's sitting over there. All right, then computer vision. So again, last year we shipped our AI labeling feature, which was sort of a first foray in how do LLMs play a role in edge AI, if you're not straight want to run an LLM directly on device. So it's essentially a way to have LLMs or other big models help you label data. And labeling can be wide, right? It can be an image classification task. I don't want to label if this is a cat or a dog. But it can also be, draw me bounding boxes around the stuff that I think is interesting. And by chaining models together, for example, here in the picture, you see first a very generic object detector, OWLVIT, that just detects all the pills. And then we have a big LLM, a big VLM, GPT-4o here, that is then labeling these based on the text that is on the pills, which is a really complex use case. And it's going to take you a lot of time if you want to do this by yourself. Together, we can chain these things together and label these data sets a lot faster. This has seen tremendous pickup. I tried to run a query on the database to see how many how many samples we labeled using this. And then after half an hour, the database was still chugging along, so I don't have the exact number, but it's in the tens of millions. Next, as Zach already talked about, we're now going to bring proper full LLMs for on-device inferencing into the studio as well. So this is a sneak preview of that interface. So you can just ask stuff in natural language about your data set. And that's what we're going to do here. So we'll set the prompt, and there's an image classification task. So classify the image as cat or dog. And then rather than having to train a model yourself, you can just zero-shot it. And this will either, in this case, will get it right in all these things. And this becomes important because the fact that I can run a VLM on device does not mean that that just magically works for everything, right? I first want to evaluate how well does this actually work on the specific data set that I'm trying to classify. So for VLM, the first thing that we're rolling out is a zero-shot understanding of image classification tasks. So this, say, cat or dog, without actually having to train a model. We will be able to have multiple labels per sample. So that becomes more important later if we're going to talk about cascades, but the make of a car, or the type of a car, or the license plate. And this will be fully integrated into the studio, so you have model testing and live classification and experiments. And you can also benchmark that against models you train yourself, right? And I think that's important because how well does this VLM actually work? The VLMs that we can run on device are going to be smaller than what we are expected in sort of the big cloud VLM world. A GPT-4 with, whatever, 1 trillion parameters is going to have a way better world understanding than a 4 billion parameter model that we can run on, even sort of the highest compute devices that we have today. So understanding how well they work and in what cases they don't work is crucial. You can't just run that LLM directly on device without doing that. So the first deployment here, I see this is, I think, for me, the biggest change of being part of Qualcomm. I sent these slides off to legal, and then they added the trademark logo after Dragonwing. Are going to be on the QCS 6490. That's the same dev board that runs the car demo that we have, the racing car demo, and on IQ9, which is the new 100 TOPS device from Qualcomm. But as always, once we ship this, we will be open to other targets very soon after. All right, then, because VLMs get all the hype, but there's still 99% of our customers are not deploying VLMs on device. We started investing in our own computer vision architectures back in 2021 because we saw a gap in models that were actually built for the edge. So the first one that we did was FOMO, which is our, an object detector on the lower end that actually outputs centroids, and that runs a lot faster than these big bounding box models. Really useful. I call it a constrained model for constrained problems. In lots of cases, I want to detect if a beer bottle comes off the production line. I don't need a really big model. I can have a very small model that just needs to be trained on that specific use case. Then we shipped FOMO AD, I think in 2022, maybe 2023. And then the HD version of FOMO AD last year. This is our visual anomaly detection block. And you saw in Zach's keynote from this morning that we see really good pickup of this in all kinds of visual inspection use cases, like with MullerTech. And today we are releasing the third one here, and that is finally, after a year after the initial announcement, YOLO Pro, which is our bounding box object detection model. And that concludes sort of our foray into new leading CV architectures. So YOLO Pro, available in Studio for everyone today, is a state-of-the-art YOLO object detection model, YOLO-style object detection model, completely developed in-house, that will allow you to do object detection on all kinds of interesting data sets. It comes with transfer learning weights available. So right now, just trained on open images, so it's good at traditional image classification or object detection tasks. But we are coming out with specialized weights soon. So you might have a model that's already base trained on an industrial data set. So if you want to deploy this somewhere in the factory, you can just fine tune on that existing model. It means you need less data and it trains faster. Very important for our customers is that this is very clean licensing. So there's no GPL and no AGPL codes in here. And this is available today in Studio. So everyone here can go try this out. Just take an existing object detection data set, create a new experiment, and go train a YOLO Pro model. It's really built for the edge because we built this completely from scratch. It also allowed us to make a bunch of choices that we found lacking in some of the other state-of-the-art object detection models. For one, the model sizes. So we can scale this from 600,000 parameters to about 35 million parameters. And just as TBD, we should have removed that. Just an indication, this can run in about 220 kilobytes of RAM in the smallest configuration. So this can even go in places where currently we can only deploy FOMO. And then on XLarge 480 by 480, on my MacBook M4 Pro, this runs 2 frames a second. That's how big that model is on the CPU. So this is really big. And then the second is that we can also turn features on and off in this model depending on the architecture that we run at. So we have a self-attention mechanism, so a couple of transformer layers in this architecture, but not all NPUs and accelerators support that. And because now we fully control this training pipeline, we can just disable attention if you want to go deploy this on an NPU or an accelerator where you don't have support for these transformer layers. And I think that's really cool, and we can continue building features that we can enable and disable depending on the silicon. And so today this already runs on general purpose MCU, general purpose DSP, general purpose MPU, but we also have NPU and GPU support for 6 vendors, Qualcomm, CEVA, Memoryx, ST, and NVIDIA, straight from the get-go, which I think is really cool, and we're going to be adding more stuff very soon. So available today, YOLO Pro. Now you have a YOLO Pro model, and then you have another problem. So let's say that I have, this is the car detection demo, the car park demo, that's also on the show floor. This is a very well working model, in all fairness. It detects vehicles. Now, the problem is that object detection models work at 1 frame at a time, right? And thus, I know that there's a vehicle, but it doesn't tell me anything. It doesn't tell me, is this a new vehicle? Was it here a frame ago? Is this box still the same box that I was looking at previously? So we shipped, about a month ago, we shipped object tracking now in Studio. And that is a flexible object tracking architecture, so a post-processing layer for object detection models. It works both in stuff that you train in Studio or stuff where you do bring your own models. So if you train something outside Studio. It works for centroids, so FOMO-style models, and it works for bounding boxes, so YOLO Pro-style models. And the only thing you need to do is basically give your object detection model, you upload a video, and then, this is the exact same video that I had before, instead of getting noisy bounding boxes every frame, I now get super clear tracking. There's vehicle with ID 0, there's vehicle with ID 6. And from frame to frame, I know that I'm looking at the exact same vehicle, which is cool. Like this big part of my application, stuff that I need to implement to make this object detection model useful, is now done for me. Now I can just write code and start thinking about, okay, my logic might be, I have an object detection model, then through the object tracking, I know when a new vehicle is found, right? That's probably what I want to do. That's the whole reason I'm running this object detection model. And then I can, for example, chain that to the VLM, and that's sort of how we tie this all together. So now I can get free-form features from this, but just prompting a VLM. And because the way that we architect this as sort of a chain of models means that this last part, the VLM part, can, for example, take quite a lot of power because I don't need to run it every frame. I can set some rules, like I only run this VLM part when I see a new car and it's been there parked for at least 2 minutes. That's when it burns some energy. And that might be a VLM that runs locally on device, if you have a higher-end device. But it might very well be, if you have an OpenMV cam, that's the moment you say, hey, now I want to burn a bit of energy to go access to the cloud, because now I know for sure that something interesting is happening here. So you create these architectures that are sort of get the best of both worlds. They run fast and small and really power efficient on device, and then when you need the power of a VLM to catch these free-form features, that's the moment that you burn a bit of energy and go to the cloud. And these cascades are quite common, right? These are not just in computer vision tasks. Think about an MCU that's doing fault analysis. If you need to run the MCU at full capacity all the time and sampling from the accelerometer all the time, you're going to burn through quite a bit of energy. If instead you could say, well, I'm running, for example, ST has these accelerometers where you can run a decision tree directly on the accelerometer, a very small one. What if I combine that? I've run the first stage of my model on the accelerometer itself, and only the moment that I see something interesting happening there, then I wake up the MCU to do my proper fault analysis. And bam, now you're 10 times more efficient. Same with multiple computer vision applications, right? You might use object tracking to find a part on the factory line. And then you run FOMO-AD to do visual inspection on that. And because FOMO-AD doesn't need to do it on the full frame, you can have a much more efficient and smaller model because it need to learn everything about or everything around that part. It can just focus on that part specifically, so you get better accuracy. And then maybe you want to either cascade to an LLM to analyze a fault or just alert a person. Hey, I'm pretty sure that I found a fault in this part. Go take a look at this. And then there's cascades where two models just run, where one model just helps clear some stuff up for the other one, like a noise suppression neural network that you want to run before your keyword spotting model. An easy way to increase accuracy. So we are working on a couple of features. They're not live yet, but they're going to be live very soon to make building these model cascades a lot easier in Edge Impulse. So the first one is that for the first time we're allowing freeform outputs in Bring Your Own Model. So traditionally, right, in Edge Impulse you could build classification models, regression models, object detection models, and anomaly detection models. And if you have a use case like noise suppression that doesn't fit in either of those things, you cannot get it into Edge Impulse, and thus you can also not deploy it, which is sort of a pain in the ass. So with Bring Your Own Model, we'll support any inputs, any outputs. And on its own, maybe not so useful, but it's very useful once you start chaining these together in a model cascade. The second one is that we are adding proper support for running multiple models in our C++ deployments. So right now we do this ad hoc. So a customer comes to us and say, hey, I want to run these 3 models on my MCU. OK, great. Then our solutions team will go take these 3 projects and then make one library for the customer to go deploy that. A bit wasteful. Now we're going to add proper support in Studio. You say, hey, I want to deploy that impulse, that impulse, that impulse. OK, here's one library. Go run that. That's very nice. This will come probably this month. And then last, and Dan didn't want to show me this little UI because he wants to do it in code, but we're going to be building a cascade builder. So a place in the studio where you can just say, hey, this is what my cascade should look like. Here's my object detection, here's my object tracker. If I've seen the same object within a minute, I want to do the cascade to a VLM, and then evaluate that whole system rather than on a model-by-model basis. That doesn't mean you can't build any of this stuff today yet, right? It's just that we're making it a bit easier. So as an example, here is something you can just run today using YOLO Pro plus an object tracker and a VLM to do it in the cascade, which is something I put together. So I did not tell my girlfriend what we're going to do. I just asked her to walk in the room. So we have a person tracker, and that's me. And if it's seen the same person for 2 seconds, it will cascade to the VLM and then ask a freeform question. What color hair do these people have, and what color shirt do they have? And you can see, right, this runs in about 25 milliseconds per frame. So this runs very, very fast. I can detect people, come in. The object tracking works really, really well. And then I still get like all the benefits of what an LLM can do. But an LLM takes 2 seconds, right? So I cannot run this in real time because then I get, 0.5 frames per second. But here, by just chaining these 2 things together, I get the best of both worlds, really fast, really responsive, low power on device, and then just burning a bit of energy the moment that I want to know exactly what is going on. So you can already do this. I've put examples on GitHub, both for object tracking, cascades, and for visual anomaly detection cascades. So you can just go run that today. Last, we put our very first release of model monitoring. This is sort of, I think, the last missing piece of what is in a system, right? Very often, up until about a year ago, we said, well, the moment that you deploy your model, we give you source code, you put it in your device, and now we're done, right? But if you're building a complete system, you also need to know how does this model keep working? Is there drift in the model? Are we seeing stuff that we don't expect, etc.? And as you're building bigger systems, this becomes important. And we also see that customers can build this themselves, and they've done that in the past, but it's much more efficient if we just build it, if we build a common foundation and customers can just plug into that. So the first release of this is now, we put out internally about a month ago. And with all of these things, right, the ability to create much more complex model chains, the ability to cascade to a VLM or cascade to a human if needed, the ability to run complex computer vision models on one end, the ability to run time series models on the other end, and the ability to monitor these models, like all of that together, that brings us to our visual inspection solution, as Zach talked about. Right? So for the first time, we're not going to just be providing a platform where people can train their model, but actually a full end-to-end inspection package, including hardware, complete software that runs on-premise, something where you can just go in, deploy this to start on your factory line, and get real insights from there. I'm really, really excited because this takes us, as Zach said this morning, it takes us from we provide you with 20% of the solution and you need to come up with the remaining 80%. Now we'll be able to ship 90% of the complete solution and then have our SIs handle that last 10%. So, last that I want to say, we are launching with Hacker Earth a new AGI contest. So if all the stuff that you've seen in the last 30 minutes, you want to go apply that, you want to build something cool with YOLO Pro, you want to go put your own chains of models together, you can win money. $30,000 in total, $12,000 for the first prize. So if this sounds interesting, if you like money, go to Hacker Earth, sign up, and start doing our AGI contest. And with that, I want to thank everyone so much. There's going to be happy hour in the next room, and see you next year.